Morning friends, here we are to discuss about the face identification problem and solution using PCA and SVM. So face identification problem basically is that you have a set of images and then there is an input image and your model is supposed to identify the person to whom this image belongs to. So here we have implemented this using a very basic PC and SVM algorithm. So we have used LFW datasets. It's a dataset of celebrities, and these are some of the sample images. And we expect the outcome to be something like this. Here we a model has tried to identify some of the samples and it has succeeded in a lot of them. So let us go through the code and let us try to understand how this code is generating the output. These are the libraries we have imported. So basically it depends on scalar library, and we have used CV2 for installation for processing the images in matplotlib library to display the graphics of the results of the classifier. So basically starts with loading the data set. You can easily load the data set from scalar library. Scalar has a lot of data sets, inbuilt data sets, so you don't need to go to any external source. Just a simple function fetch underscore lfw underscore people and you will be able to download the data set. So there are altogether 3023 images, each of 62 cross 47 pixels. So total number of pixels per image is 2914 and there are 62 celebrities. So per celebrity you can say that there are around 50 images. Some of the images of some of the samples from the data sets: Winona Ryder, Jean Chrétien, Carlos Menem, Ariel Sharon, and Alvaro Uribe. So these are some of the celebrities and their images are there. We have written a small pre-processing function to improve the quality of images. So you can easily get this code, and there is nothing much to discuss about it at this point of time because our primary purpose is to understand the model. So what we have done here, first we have converted this into uint8 because CV2 works on integers, and by default it was a floating number. So we have converted our float images into uint8, which is from 0 to 255. uint8 is available in the numpy library. So np is our numpy library. Then we have processed the image, okay, and scale the data, crucial for, and we have done some scaling to make it suitable for PCA. So PCA algorithm is basically principal component analysis. So basically we are trying to reduce the number of damn features of the input image. So I will run the code now for you. So PCA basically does what? It reduces the size of the data that has to be processed. So in order to use PCA, we have to create a scaling of the data. So this is crucial for the scaling of data, and some kind of transformation is also required. These two functions are basically improving the quality of the image so that it can be easily used for PCA analysis. All right, now, and after this we can go to the actual algorithm. So here we have used 75 components. So basically what we are doing is we are reducing the size of the image to 75 pixels. instead of 62 cross 47 that it was before. So the algorithm is doing that, but at the same time, same point amount of time, it is also keeping the variance to 95%. So 95% of the information in the image is retained by this 75 pixels. So which of those are important pixels? That is what PCA is giving us as an output. These pixels are forming an image, and that image we are calling it eigenfaces. Okay, so I have generated eigenfaces and I have visualized them. So let us see the eigenfaces of some of the images that we have obtained by applying PCA algorithm. You can see here these are all eigenfaces. They are obtained by reducing the pixel size. So earlier we had, if you go back, we had 3023 images of each of the 62 cross 47 pixels, and now still have 3023 images, but each image is of total size of number of pixels in the image is 75, but they are very much meaningful in identifying the person. So a data set has reduced considerably. You can say that it's almost 95 or 96% reduction in size. Next we will go to the training of the classifier. Now we can move to the training of the classifier. So for classifier training, we'll use the SVC library available in sklearn. Okay, and this is implementation of SVM algorithm. So this code is now just splitting the data set into training and test sets. So there's some images are 75% of the image will be used for training purpose, and 25% of the image will be used for, so here 0.25 means test size is 25%. Okay, so now we are implementing the SVM algorithm using the radial basis function classifier. Now, why we are using this classifier? Because the images might not be easy to classify in the lower dimensions, so we are trying to go to the higher dimensions to make it easily classifiable. So there's huge of lot of mathematics in it, but you can say that instead of, very simple example would be, right, instead of using a two-dimensional data where it is very difficult to classify them, we're putting them into three-dimensional data so that they can be classified. So it could be more higher dimensions possible to use. And then we have used the fit function to train the model. Okay, so here we have used the fit function to train our model. Okay. Now this is the classification part. So this, till this part, our classifier is ready. Okay, so we are ready with the classifier. Now we'll check the performance of the classifier, and we will also test the classifier on some sample inputs. So we are using the test data that we have generated above to test the classifiers. Okay, and the performance obtained from it is 0.61, accuracy of 0.61. It's not a very good result, and there is lot of scope of improvement, but we can move ahead here at this point of time and check some images and can get these images from the dataset itself. So these are the images we are coming. It's coming to our variable test underscore images. Some images we have tried to obtain, and then see here there are a lot of positive results. Now 0.61% accuracy means that there could be sample where could be very high number of positive results, there could be sample could be low number of positive results, but the results are optimistic. And we can say that our classifier can get ahead and get more results if we work out on its performance. So here I would like to discuss about the size of the component. So instead of 75, we can increase it from 75 to say 95. All right, and then we run all the cells. Now, two things has to be noticed here. The first thing is that the speed of the execution. You can easily see within a second the classifier is ready to give you results, and it has given us a result also. The second thing is that the accuracy has increased to 0.62. Right. So if we increase this number of component, accuracy we can easily increase. So we can go to much higher level of accuracy, and after this we have got the results also. So again, Vajpayee has been predicted as straw, so there is a false result, but Sharon has been correctly predicted, Bush has been correctly predicted, and Powell has been correctly predicted. So there are good results also. So this code is really going to help us a lot in generating the more meaningful solution. Thank you so much for your time.